Hi, my name is Salvatore Ventura, and in this video I will demonstrate features and capabilities of the Cisco Nexus Fabric Manager. The demo environment consists of a greenfield deployment of Nexus 9000 switches in spine leaf topology, and it includes few hosts as end devices. I will cover several workflows, from the fabric bring-up to providing layer 2 connectivity to the hosts and more. The first step will be to discover all the devices in our fabric. For this, we will start by importing one of them as seed for the automated discovery. Once the NFM has established connectivity with the seed switch, it will automatically install the agent that will be used for all the communications. As the agent starts, it begins to relay all the information of the switch back to the NFM. This information includes the CDP neighbors of the seed switch, which the NFM can then use to proceed in the auto-import of the remaining switches in the fabric. Agent installation and data retrieval is repeated for all switches. Through the same CDP discovery, the NFM will also get awareness of endpoint devices, which are listed in the Neighbors tab. Cisco Nexus 9000 switches are initially imported in monitored mode, which is a read-only admin state. While in the state, the NFM will gather stats and counters on these switches, but will not push any configuration. In order to start building the fabric, we need to change this admin state from monitored to managed. Once NFM is granted managed privilege on the switches, it will start the steps required to initialize the fabric, which consists in the configuration of several features and components, like layer 3 port channels between spine and leaves, and the bring-up of OSPF, BGP, and EVPN for the underlay. All of that is automatically initiated and managed by the NFM. Let's have a look at the Interfaces panel. In this particular panel, you will see all the interfaces that belong to the fabric, and you will notice that the NFM will automatically categorize interfaces based on their connectivity. For example, right now we are looking at all of the infrastructure interfaces, which are the group that consists of switch-facing, spine-to-leaf interfaces, and peer links. You see that as the configuration is being propagated, these port channels are getting automatically created. The system administrator will instead focus their attention on perimeter interfaces, where endpoint devices like host, storage, layer 4 to 7 devices will reside to consume the connectivity offered by the fabric. Let's look at the case of a dual-homed server. The first step is to search for the fabric interfaces that connect that server. By typing its host name, the user interface provides a list of interfaces, and creating a port channel from there is a simple task. The NFM, though, goes the extra mile, and based on the knowledge it has of the specific topology, it will automatically create a VPC instead of a simple port channel. The next step will provide layer 2 connectivity between two endpoint devices in our fabric. In order to do that, we will create a new broadcast domain and add those two endpoints as members. In this next segment, I want to show the topology view offered by NFM and all of the features it comes with. The topology view offers two representations, a compact one and an expanded one. The compact topology highlights the layout of the fabric at a macro level, where you can easily visualize the relationship among its various parts, a central cluster of spines and individual cluster of VPC peer leaves that provide connectivity to racks of end devices. When you expand this view, you have full visibility and access to the various elements, including switches, interfaces, port channels, and endpoints. You can also perform searches based on various strings, for example, host names. But the biggest feature is for this topology view to be fully actionable. And I'm demonstrating that by performing the same tasks of creating a port channel and broadcast domains on this view. Once you have several broadcast domains, the topology view allows you to highlight their extension on the fabric and perform contextual searches. Let's remember now about broadcast domains 110 and 120, as we will use them in the next segment of the demo. In this segment, I want to show how to create gateways for those broadcast domains and how to partition the traffic in individual VRFs. Let's start by creating a new VRF for our tenant 1. The next step will be to create individual gateways for broadcast domains 110 and 120, both of which will use the same VRF. Of course, you can create multiple VRFs and provide tenant segmentation inside your fabric. A lot has happened on the NFM UI so far, from the initial fabric discovery and bring up to the creation of Anycast gateways and VRFs. Let's take a look at what the configuration of a switch looks like by going to its CLI. I'm going to use one of the leaves here. As you would imagine, all of those steps on the user interface resulted in a lot of configuration that has been pushed on the switches. How much exactly? I can tell you that exactly by looking at how much configuration was there at initial time of import and how much there is now. The numbers come out to be shy of 300 lines of configuration. Then repeat that across the remaining 5 switches on the fabric. Let's now look at what happens when you add a new rack of switches to this existing fabric, which has already plenty of operational configuration. As the new switches get connected to the fabric, the NFM will discover their presence through their neighbors, and it can automatically import them. As we saw in the beginning, these 2 new switches start in monitored mode, so let's have a look at their initial configuration before we make them part of the fabric. As you can see, the initial configuration is typical of Greenfield, not much there. As we flip their management state from monitored to managed, the NFM will merge them into the existing fabric. And you can see that as this process is happening, more and more configuration gets synced onto the new devices. Of course, the topology view now will reflect the new rack addition, as well as the new endpoint devices in the Neighbors tab. The Cisco Nexus Fabric Manager provides image upgrades for the Cisco Nexus 9000 switches. The NFM itself hosts an image catalog where you can upload the latest NXOS releases, and then use those images to perform upgrades. To define an upgrade, you select a list of switches and assign an image from the catalog and the desired upgrade strategy. You can then manually start and track the upgrade at a later time, but also update its properties, including a newer available NXOS image and or the set of members in the group. The Cisco Nexus Fabric Manager simplifies the distribution of common configuration attributes to multiple objects through the use of profiles. For example, an interface profile allows the user to centralize any or all of the properties that you can see on screen and share that configuration across multiple interfaces. Same capability is offered for switch configuration through switch profiles. As changes to a profile are automatically propagated to all of their linked objects, it makes interfaces and switch profiles a powerful tool to centralize management of common configuration elements across the fabric. Profiles can also be elected to be assigned by default to elements as they join the switch pool. The Cisco Nexus Fabric Manager provides detailed view for the various objects it manages. Let's start from a switch, where you can see system information and also tabs dedicated to its interfaces and neighbors. A port channel offers a different set of information, like traffic counters, its member interfaces, and the list of broadcast domains it belongs to. An individual interface is very similar. Notice that traffic graphs can show information at different levels of aggregation and the time span. You have also noticed that all the objects have a Faults and History tab. The history shows all of the events that have involved this object and any modifications to its fields. Similarly, faults involving these objects will be listed in the Faults tab. Another facility provided by NFM is the ability to store comments on individual objects. This allows, for example, the operations team to keep a log of their actions within the same system. The Cisco Nexus Fabric Manager generates faults for error situations that occur in the fabric. In most cases, the NFM can take an autonomous remedial action, but for other cases, user intervention is required. In those cases, the NFM might propose few remedial actions for the system administrator to select from. This concludes the Nexus Fabric Manager demonstration. Thank you very much.